U.S. Navy expands unmanned surface vessel operations at RIMPAC 2026 with Saildrone Surveyor. The U.S. Navy is expanding the operational use of unmanned surface vessels USVs during Exercise RIM of the Pacific RIMPAC 2026, reflecting a significant shift toward distributed maritime operations in which autonomous systems increasingly complement crewed warships. On July 8, 2026, the Saildrone Surveyor SD-3001, an uncrewed surface vehicle, departed Joint Base Pearl Harbor-Hickam, Hawaii, to participate in the world's largest multinational naval exercise, demonstrating how persistent autonomous maritime surveillance can strengthen fleet-wide maritime domain awareness across coalition forces. The deployment reflects the growing integration of unmanned systems into U.S. Navy operational concepts. According to the U.S. Navy, unmanned and remotely operated vessels extend the reach of interconnected sensors carried by crewed ships, enhancing the multinational force's ability to detect, classify, and track maritime activity over vast areas while reducing demands on high-value naval assets. Today, unmanned surface vessels have evolved from technology demonstrators into key components of the U.S. Navy's modernization strategy. Exercises such as RIMPAC increasingly serve as operational laboratories where autonomous vessels operate alongside destroyers, amphibious assault ships, submarines, maritime patrol aircraft, and allied naval forces to validate concepts for future distributed fleet operations. The participation of Saildrone Surveyor reflects the Navy's broader effort to build a hybrid force in which autonomous systems perform routine surveillance and reconnaissance missions while crewed combatants focus on missions requiring advanced combat capabilities. EZOIC. The Saildrone Surveyor, designated SD-3001, represents one of the largest autonomous surface vessels currently supporting U.S. Navy operations. Unlike the smaller Saildrone Explorer, which was originally developed for scientific and environmental data collection, the Surveyor is optimized for persistent blue water missions lasting several months without direct human intervention. Its larger hull provides significantly greater payload capacity, allowing the integration of intelligence, surveillance, and reconnaissance ISR sensors, hydrographic equipment, meteorological instruments, and electronic monitoring systems while maintaining exceptional endurance at sea. Technically, the Saildrone Surveyor is a 20-meter autonomous surface vessel engineered for long-endurance oceanographic, hydrographic, and maritime surveillance missions. Propulsion is provided by a rigid wing sail that harnesses wind energy, while solar panels generate electrical power for onboard computers, autonomous navigation systems, communications equipment, and mission payloads. Its modular architecture can accommodate multi-beam echo sounders, side-scan sonar, passive acoustic sensors, surface search radar, electro-optical and infrared cameras, automatic identification system AIS receivers, and atmospheric and oceanographic sensors. This sensor suite enables the vessel to conduct seabed mapping, monitor underwater and surface activity, identify commercial and military shipping, collect environmental intelligence, and transmit near-real-time operational data to naval commanders via secure satellite communications without requiring a crew on board. Powered primarily by renewable wind propulsion and supported by solar-generated electrical power, the Surveyor can remain deployed for months while covering thousands of nautical miles. Such endurance provides an operational advantage over conventional patrol vessels, whose deployments remain constrained by fuel consumption, crew rotations, and maintenance requirements. Persistent presence across contested maritime regions has become an increasingly important capability as the U.S. Navy seeks to maintain continuous awareness across vast operational areas without committing additional crewed warships. The operational value of vessels such as the Saildrone Surveyor lies in expanding the U.S. Navy's sensor network rather than replacing destroyers, frigates, or other crewed combatants. Contemporary naval warfare increasingly depends on detecting and tracking potential threats before they can challenge high-value naval forces. Every additional autonomous surface vessel operating independently expands the fleet's surveillance footprint and contributes sensor data to distributed command and control networks. This operational model supports the U.S. Navy's Distributed Maritime Operations DMO concept, which seeks to disperse forces over wider operational areas while maintaining shared situational awareness through resilient communications and network sensors. Within this architecture, Unmanned surface vessels serve as forward-sensing nodes that monitor choke points, track maritime traffic, support targeting processes, and extend reconnaissance coverage without exposing sailors to unnecessary operational risk. This capability is becoming increasingly important as strategic competition intensifies across the Indo-Pacific. Monitoring immense maritime spaces using only crewed ships and aircraft requires substantial financial resources and personnel. Autonomous surface vessels provide a comparatively low-cost method of maintaining persistent maritime domain awareness while allowing high-end combatants to focus on deterrence, sea control, and power projection missions. The deployment of Saildrone Surveyor also illustrates the U.S. Navy's broader transformation toward a more diversified autonomous fleet. Alongside the medium unmanned surface vessel MUSV and large unmanned surface vessel LUSV programs, the Navy is integrating autonomous technologies into logistics support, mine countermeasures, anti-submarine warfare, electronic warfare, and intelligence collection. Together, these initiatives reflect a deliberate shift from experimentation toward operational integration as autonomous systems become routine contributors to fleet operations.